Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 11, Lesson 3 on more work with standard deviation. In the last lesson we sort of started to delve into this thing called standard deviation, and in this lesson we just want to explore it more. So let's get right into it. Right, the standard deviation of a data set. The standard deviation is the most used measurement of variation in a data set, right? And we've already seen these three different measurements: the range, the interquartile range, and now the standard deviation. And by far, the standard deviation is the one that in real applied statistics you see come up the most. Now, it can be roughly interpreted as the average distance that data points lie away from the mean. All right. Now, let's kind of get into that right away in exercise number 1. A math final was given to 9th graders at a large high school. 20 random scores were sampled from the test to get a sense for how students scored. Their distribution is shown on the dot plot below. All right, great. So we got this dot plot. We've taken this large high school math final. We randomly grabbed 20 of them to kind of get a sense for how the overall population did on this test. Okay, and there's our dot plot. Now, in letter A, let's take a look at what they ask us to do. Enter the data on your calculator and find each of the following statistics for the sample. Round to the nearest tenth. All right, so let's take a look at how this is done on the calculator. Now, as I've mentioned in previous lessons, how you enter data on a given graphing calculator really depends on what calculator you're using. Whether you're using a Texas Instruments 84 Plus or a TI Inspire the way I'm going to use, or a Casio or Hewlett Packard or whatever you're using, how you enter the data is really different. Now, either way, on the TI Inspire or any other calculator, entering data from a dot plot can be kind of a challenge, right? Now, on the TI Inspire, I'm going to add the data by going into Add Lists and Spreadsheet. Now, again, it's a little bit weird because in order to add this data, I need to be able to see it, and that's kind of a challenge. So I'm going to actually put this on handheld only so it becomes a little bit smaller. Okay, but for me, and everyone else, no matter what calculator you're using, you really have to keep in mind, okay, there we go. Let me put it over here so we can see the first data set, right? That you've got to put in a 73, a 75, a 77, an 80, and then two 81s, and then three 82s, and then four 83s, and then two 84s, and then one 85, etc., etc. And it is really critically important that you do this correctly, right? Your teacher can't give you any credit if you, misdo some of these things and you put either the wrong numbers in or whatever, because your calculator is going to be calculating the mean and the standard deviation for you. So my piece of advice is always enter the data once, check it over, right? Check it over again and then run the statistics. So pause the video now, right? Enter this data into whatever lists or spreadsheets or whatnot you have on your graphing calculator, and then we'll proceed from there. All right, one of the great things about the TI Inspire is it allows me to put the data in ahead of time. As long as I open up the right program, I'm going to open up this particular document. I don't want to save my last one, and there they are, right? So these are my scores on that test, right? My 73, 75, 77, etc. In fact, if I kind of pan down far enough, you start to see some of those repeats, right? My 281s, my 382s, etc. Now, I want my mean and my standard deviation. That's all I need from this data set. I don't need my quartiles or my medians or anything like that. So I'm going to hit Menu. I'm going to go to my statistics option. I'm going to go to stat calculations. I have one variable, right? That's all I want. Okay, I've only got one list, no more than one list in this case. So I hit OK. I'm not going to worry about the rest of these things as long as my data is in A. Although, if I click on this, right, I had actually put it in scores. So I can do that, hit OK, and there's my data. I mean, it is fast. And strangely enough, it's right on the standard deviation, but let's first grab our mean, right? Our mean, as we've mentioned in previous lessons, is this x with a little bar over it. In fact, it's called in statistics x bar, and our mean happens to be 83.2. Let's find that standard deviation right away. That's right down here. That's that little s, right? SX. Here, it's really ugly, 5.463, etc. So rounded to the nearest tenth, it's 5.5. So we have 83.2 on our sample mean and 5.5 on our sample standard deviation. 83.2 and 5.5. Let's get those in. 83.2 and, whoops, 5.5. And again, you know, it's easy enough, right? You can interpret mean, and you've been interpreting mean for years now, right? The average score out of these 20 was 83.2, and, right, roughly, the average distance that any given score was away from the mean was about 5.5 points. Okay, so now let's get into letter B. Using your answers to A, construct an interval for all values within 1 standard deviation and within 2 standard deviations from the mean. Now, in the last lesson, we constructed an interval for all the values that were within 1 standard deviation. We didn't do it within 2 standard deviations. What I'd like you to do is pause the video right now and first figure out that interval that is for all the values that are within 1 standard deviation of the mean. All right, now to do this, it's very simple, right? I want to take the standard deviation and I want to subtract it from the mean, and the standard deviation and add it to the mean, okay? So we're going to do 83.2 minus 5.5 and 83.2 plus 5.5, right? What would that be? 78.2 and then 77.7, I think. Yep, that looks right. And then here, when I add, that seems to always be easier for me. That's 88.7. All right. So every single one of the data points that are between 77.7 and 88.7 are closer than 1 standard deviation to the mean. Now, how do I do the 2 standard deviation interval? Well, for that, it's really simple. I want to subtract 2 standard deviations away from the mean and add 2 standard deviations to the mean. Now, we can do this kind of with a formula by literally just doing this. 83.2 minus 2 times 5.5. I think I'll probably do this on my calculator. And then 83.2 plus 2 standard deviations. All right, it's really that simple. Just, okay, I'm going to subtract off 2 standard deviations. I'm going to add 2 standard deviations. Real easy. So we'll just do 83.2 minus 2 times 5.5. That's going to give me 72.2. All right, and then I've got 83.2 plus 2 times 5.5. Make sure that all looks good. Great. And that's 94.2. Okay. So now what I know is that every value that is between 72.2 and 94.2 is within 2 standard deviations of the mean. Excellent. Okay. So let's now take a look at letter C. Mark the intervals you found from B on the dot plot, then count the number of data values within each interval and calculate the percent of the data set that falls in each. Whew. All right. Well, a little bit hard because we don't see those intervals anymore. So let me just, I'm going to kind of pan this up for a second. That's 77.7 all the way to 88.7. And this one was 72.2 all the way up to 94.2. All right, so I love doing this on dot plots. It's always kind of fun. Let's start with the 77.7 and 88.7, obviously. So what I'm going to do is I'm going to look actually for 78, right? 78 is right there. So if I kind of go like this, right? There's my 78 and 88.7, right? I kind of want to like go up to 88, but not all the way to 89, right? So this is one standard deviation. Standard deviation is oftentimes abbreviated by SD, no great surprise there. Okay, that's simple enough. And how many values fall within one standard deviation? Well, I just have to count the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 values fall within that. We'll calculate the percent in just a little bit. Let's let that go for right now. Now for two standard deviations, that's 72.2 all the way to 94.2. That means that the first one that would get in there would be a 73, which means that one would. Let me kind of put a little like box here, right? Oops, that might have been like the worst vertical line ever, right? 72.2 would be roughly there. 94.2 would be roughly here. So everything within these two is two standard deviations, okay? And that's almost all of it, right? There's 20 total values, and every single one of them is within two standard deviations except for that one. So there are 19 there, okay? So we've done almost everything in this problem now. We know 14 values fall within one standard deviation and 19 fall within two standard deviations. We just haven't figured out the percent yet, but that's easy enough to do, right? I can do 14 divided by 20, and I can do 19 divided by 20, all right? I could do that just simply on my calculator. It's also pretty easy because of the 20. That's going to be 19%, and that's going to be multiplied by 100, that's going to be 70%. So I see that 70% of the data fell within one standard deviation of the mean, and 95% of the data, almost all of it, fell within two standard deviations of the mean. Now, this general trend happens all the time. The standard deviation rules of thumb, I don't know why they're the rules of thumb, but that's what they are. For typical populations, now this is important, typical populations, okay, meaning most, but there could be some weirdo populations out there that this isn't true for. But for typical populations, about 67%, and that's 2/3, about 67% of all the data will fall within one standard deviation of the mean. About 67% or 2/3 of the data. Now, for typical populations, about 95% of all the data will fall within two standard deviations of the mean, right? So that's the vast majority of it, but not all of it. We don't expect all data to fall within two standard deviations of the mean, but the vast majority of it will. So let's take a look at a little problem on that. Exercise number 2. The average time that it takes to run a marathon is 278 minutes with a standard deviation of 63 minutes. Which range of times below would encompass almost all of the finish times of marathon runners? Okay, well here it's really all about this. Almost all, right? Almost all implies that we're really looking for an interval of two standard deviations. Two standard deviations. So see if you can create the two standard deviation interval for this particular problem. Pause the video now, use your calculator, and figure out the two standard deviation interval for these marathon times. Now keep in mind, the one standard deviation interval, that would only get about 2/3 of all the times, which isn't almost all, right? You know, if I said I'm giving you 2/3 of a pizza, I couldn't claim that you're getting almost all of it because I'm getting 1/3, right? You're only just getting twice as much as me. But the two standard deviation interval, that's going to be 95% of all the times for this marathon are going to fall within that. So how do we do that? All right, so we take 278 and we're going to subtract off 2 of those standard deviations, and then we're going to have 278 and we're going to add 2 of those standard deviations. Again, simple enough. Let's grab our calculator. Let me just real quick try to clear this out. That's good. A little bit better there. So 278 minus 2 times 63. And 278 plus 2 times 63, might as well just get them both down here right away. 152 to 404. By the way, keep in mind that those have the exact same units as the data, right? So there it is. 152 to 404 minutes. All right. 2 standard deviations. Within that, you will get almost all the data. Okay. Let's keep working with standard deviation. Because the standard deviation is a rough measure of the average distance a data point is from the mean, we can think of the interval of values that's only 1 standard deviation or less from the mean as representing the typical values of a data set. All right, so this is similar to how we think about the IQR as representing the typical values. Now we're kind of broadening that a little bit, right? The IQR is the middle 50%. You can kind of think of the 1 standard deviation sort of interval as being the middle 2/3 of the data. A little bit trickier to think about, but still, it's oftentimes used that way. Let's take a look at exercise number 3. A spelling quiz with 50 challenging words on it is given to 250 students. The mean number of words spelled correctly was 21, with a standard deviation of 8. Letter A, what range would represent the typical number of words a person answered correctly? Okay, so again, it's all about this typical number, right? And that implies that we're talking about the 1 standard deviation interval and not the 2 standard deviation interval. That's not the typical range. That's like almost the entire range. So pause the video now and see if you can figure out what that 1 standard deviation interval is. All right, well, it's actually pretty simple. I don't even think we need the calculator on this, right? It's going to be 21 minus 8, which is 13, and 21 plus 8, which is 29, so 13 to 29 words. Right? So anybody that kind of answered anywhere between 13 to 29 words, well, that's typical, right? That's not unusual at all that you might answer between these 2 values in terms of the number of words you spelled correctly. But now let's take a look at letter B. This is an interesting one. Mia spelled 41 words correctly. How can we tell that this is highly unusual, right? Not just unusual, but highly unusual. Like you could claim that 32 words, that's unusual because it doesn't fall into this. But 41, highly unusual. Play around a little bit with that and see why that might be a little bit strange. Well, let's take a look at the 2 standard deviation interval, all right? That's pretty easy because all I have to do is subtract 16 and add 16, right? So 21 minus 16 would be 5, and 21 plus 16 would be 37, right? So 5 to 37 has 95% in it, right? So 95% of everybody that takes this spelling test is going to get between 5 and 37 words correctly. And Mia has 4 words more than the upper level there. So Mia, she probably is spelling better than well, she's certainly spelling better than 95%. She's probably spelling better than, 97, 98, maybe even 99%. So Mia is outside, that's the term we use for it, outside of the 2 standard deviation interval. So her score is very unusual, right? Depending on how you think about what unusual is, right? But you could think about it even in terms of heights, right? So, you know, for male heights, grown male heights, the 2 standard deviation interval is probably going to go from about 5'2" up to about 6'3" in terms of those heights, with a mean maybe right around 5'9", 5'10". So all of a sudden you get somebody who comes along and they're, let's say, 6'11", right? They are way outside of that 2 standard deviation interval, and so they have a very unusual height. It's the same way here, right? 95% of everyone would get between 5 words and 37 words spelled correctly. By the way, it also works on the other end. If you had somebody come along and they only spelled 2 words correctly, that would also be very unusual. But Mia has a score that's highly unusual on the upper end. All right, one last problem. Exercise number 4. The histogram below shows the distribution of 200 vehicle speeds taken on an interstate highway. The mean of the speeds was 68.4 miles per hour, with the sample standard deviation being 9.2 miles per hour. Letter A, construct the 1 standard deviation and 2 standard deviation intervals about the mean and illustrate them on the graph. All right, well, why don't you go ahead and construct those 2 intervals? They'll be a little bit messy, all right, and then we'll talk about how we can show them on the graph. All right, well, here we go, right? So for the 1 SD interval, right, we're going to have 68.4 minus 9.2 and 68.4 plus 9.2. Okay, let me bail out of here. So let's see, 68.4 minus 9.2. And 68.4 plus 9.2, and yes, I know those aren't on the screen. I'll bring them back. So we have 59.2 to 77.6. All right, and then for the 2 standard deviation interval, we'll have 68.4 minus 2 times 9.2. And 68.4 plus 2 times 9.2. All right, so very similar, 68.4 minus 2 times 9.2. And 68.4 plus 2 times 9.2. And we get 50 up to 86.8. 50 up to 86.8. All right, that's all we should need our calculator for on that. Let's go up to the full screen. All right, so there we have it. So, you know, roughly 2/3 of all the cars will have speeds between these 2, right? And roughly 95% of all the cars will have speeds between these 2. Let's illustrate them on the graph. I think I'm going to change the color here to red just so that it makes it a little bit more vivid on here. Right, the 1 standard deviation interval, I need to like ballpark where 59.2 is on this. It's not the easiest, but it should be really, really close. Oh, that's not what I wanted. It should be really, really close to 60. And then 77.6, that should be roughly between 75 and 80. Right, so that's going to be my 1 standard deviation interval. And then 50, that's easy to find. That's going to be right here. And 86.8, again, that's going to be bigger than 85. That's not great, but it's not terrible. And 2 standard deviations. And you can really see even from the histogram that sure, you know, there is a lot of data between these, but then almost all the data falls between these 2 outer ones, which kind of makes sense. All right. So let's do one final little piece here. Let me change back to blue. All right, letter B asks us to do the following. Make a statement about the typical speeds that people are driving on this interstate. All right, so if you were doing this study and the question, the statistical question was just, what is the typical speed that people drive on this highway, right? What would you want to say? What would your answer be? Pause the video now and write something down. All right, so what I would say, again, it's all about 1 standard deviation, right? That's the typical speeds. Typically, people drive between 59 and 78 miles per hour. Now, I don't think that you'd miss any points if you said 59.2 and 77.6, but oftentimes in statistics, right, we're looking for a more general answer. And whether we use 59.2 or 59, 77.6 or 78 probably doesn't make much of a difference. And if you're just trying to explain this to sort of like the average person who might be asking this question, then saying 59 and 78, that makes a lot of sense. All right. Let's summarize. So one of the things we really concentrated on today with standard deviation was how many data values within a data set fall within one standard deviation of the mean, and how many fall within two standard deviations of the mean. What we noticed was that in a typical population or a typical sample, about 2/3 or 67% of all the data will fall within one standard deviation of the mean. And almost all the data, 95%, will fall within two standard deviations of the mean. Side note, once you go up to 3 standard deviations of the mean, it's over 99% of all the data that will fall within 3 standard deviations of the mean. Okay, now we're going to be working more with standard deviation throughout the rest of this unit, so don't worry about it if you're still a little bit foggy on it. I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.